Okay, in this question, as you see, the two blocks are in contact with each other, and according to the question, this is a force which is accelerating these two blocks, and these two blocks are placed on a frictionless surface. And in this question, you have to find out the force that is exerted by the mass on this mass small m, right? Means the larger mass on the smaller m. So let's find this. I will explain this question by two methods. The one is very easy method and other one is a relatively difficult one. Okay, so first of all, as the surface is frictionless stated over here, and all the forces which are inside the system, right? So I'm assuming this is our system, all right? What are the forces which are inside the system? The one is the normal force, the weight of this mass, the normal force, and the weight of this mass. And the other two forces are also the force exerted by the smaller object, the smaller block on a larger mass, and the force exerted by the larger block on the smaller mass. These are the forces which are balancing each other. Overall, they are cancelled out, and I can say this is the only force which is accelerating the whole system. So, if it is accelerating the whole system, and this is the only unbalanced force, if you look at the system, so then I can first of all apply the net force, Newton's second law, that says that the total mass times acceleration. What is the total mass? That's the sum of these two masses times acceleration, and we can find out the equation of acceleration, that is equals to the applied force divided by sum of these two masses. Now this equation is very crucial to solve this question. Okay, so first let's move towards the easier method. So if you see in this diagram, I'm going to draw the free body diagram of this mass over here. And so we are going to suppose that this is a smaller mass and how many forces are exerted on it. So as I already told you that this is a normal force which is which is balanced by the weight, so mg. All right. The force that is applied directly, and that must be larger force than this force. Okay, so this is our applied force, and this is a, kindly pay attention here, that this is a force, dear students, which we actually want to find out. I'm going to write it m on small m, right? M, capital M on small m. This is a force that we want to calculate in this question. All right, now let's draw the free body diagram of the second block, which I'm going to draw here. And this is the larger mass. Of course, the normal force will be also larger on it. Let's say Fn prime, as well as it is equals to the weight, capital Mg. Now, which one is the third force? It's not applied force. Applied force is directly exerted on the first mass, this smaller block. The force that is directly applied on this one, and that is actually the unbalanced force. So I should draw the same length of vector. Okay, students, this is the force exerted by smaller block on the larger block, and I'm going to write it like F small m on capital M. This is the actually in a magnitude, this is the same force as this force in magnitude, but you see the directions are opposite, and I'm talking about Newton's third law. Okay, now this is an unbalanced force, dear students. Can you apply Newton's second law right now? Because this is a force that is a cause of acceleration in a larger mass. That's why we can say it must be equals to capital Ma, because there's no any other force along x-axis that we can put in this equation, right? So if this is capital Ma is the force, is a magnitude of this force, then I can say this should also be capital Ma. All right. So that's why the right answer for this question is option B. Now let's quickly see the second method also. uh, Over here, if I write a equation, so students, in the second method I will apply Newton's second law by writing F minus F capital M on small m. Just assume now you are applying the different method, you don't know its value, that it is equals to capital Ma. All right, this is a resultant force for the smaller block. This is a net force which is causing acceleration in a smaller block. So I'm writing small ma. Okay, so I can write F minus ma is equals to Fm on small m. Right, now you know the value of acceleration, which is actually F over capital M plus small m. Okay, can we take this common from this on this side of equation? So what we will get here, it will be 1 minus small m over capital M plus small m is equals to the required force. And if you can also write it like m plus small m minus m divided by m plus m. If you don't understand this step, please ask me question. Okay, and then if you further solve this step, so then we will get this one, and this one is cancelled out, and we get capital M over capital M plus small m. All right, now I'm going to rearrange it. I'm going to take this capital M outside, and inside what we have, F over capital M plus small m. Do you recognize this thing, that this is specifically equals to the acceleration that we had already made equation? Okay, so that's why can I say that this is equals to capital M times A. Hence this is our answer, that is same which we had already find out. So option B is the right answer.